Okay. All right, guys, so we are doing composition of function. You've done this before, like you've done f of g of x or f of 2 or something like that. Realize the notation. This one throws people off. That little O, that doesn't say fog. That means f of g, okay? So don't be scared of that. These two notations mean the exact same thing. Okay, that's what this is telling you. They are the same. We are actually not going to worry about domain. So that's going to make this actually a whole lot easier for you guys. We're not going to worry about algebraic domain right now, really at all. So we're just going to do the composition. So let's just jump in and see if you guys remember how to do this. So I give you two functions here, f of x and g of x. We're going to start with f of g of x. One of the biggest things, you need to actually like label it. And if you want to write it this way instead of the little O, go for it. But get in the habit of actually telling me what you're finding, right? So I know which one is f of g and which one's g of f, because they are different. So f of g of x. I take the g of x function over here. Yep, anywhere there's an x. You guys remember this? Okay. All right, so x minus 4 quantity squared plus 2 times x minus 4. And then it is just simplifying from there. X minus 4 squared, that's not just x squared and 16. What does it become? X squared minus something. You're right, it's 8x. Yeah, because you're going to get a 4x and another 4x. Yeah, okay. So 8x plus 16, and then distribute your 2 over here. So plus 2x minus 8. So your final answer will be x squared minus 6x. You're not solving, no. You're just doing the composition. Yep. No. That's what f of g of x is equal to, and that's it. And you're done. All right, let's do g of f of x over here. Are you having desk troubles? Oh, okay. It's like tilted too. I don't like that desk. Yes, Ben. Yeah, absolutely. Yes. We go the other way. Guys, try the other one. No, 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 no. Just do g of f of x. I don't know. It's musical desks day, guys. You what? It is. There's nothing to really do with this one, right? So I plug it in, x squared plus 2x, and then minus 4. Is there anything to simplify? No, and we are done with g of f of x, okay? We're starting simple, right? We're going to have radicals, we're going to have fractions, things like that. But the basic idea of what we're doing, we get, right? It's the same process, it just might have messier algebra. Okay, so let's do the next one together. And we're not going to do both on every single one of these examples because it's kind of tedious. Let's do just f of g of x on this one. Actually, no, this one we'll do both, but others we won't do both. Fog.
So it's easier to multiply.
No, I don't like that. It just doesn't make me.
Yeah, I prefer Fox. I don't have to worry about it.
No, I don't like it.
Yeah, I do.
And then if you X squared plus 2. Do you need to, if you have x squared minus 1, put them into 2? Like x minus 1, x plus 1?
Let's go through it together and see if I answer what you're asking. So again, plugging this into both x's, right? So I'd get x squared minus 1 over x squared minus 1 minus 1. Okay? So that's x squared minus 1 over x squared minus 2. The numerator does factor, like you could write it x minus 1, x plus 1, but it's not going to simplify with anything because that denominator does not factor nicely at all. So you're just done. Like, that's it. Okay? All right, let's try g of f of x. All right, guys, you are plugging this entire fraction in over here. So we got to do a little bit of work on this one. So x over x minus 1 squared minus 1. So x squared over, when I square that denominator, what do I get? Plus 1. X minus 1 squared is x squared minus 2x plus 1. Right? FOIL it out. X minus 1 squared. Right? Okay. So we're not done with this one. Yeah, well, I need a common denominator here, right? Yeah, so I need to take numerator and denominator. Okay. We're almost there. So guys, your denominator is just x squared minus 2x plus 1. Think about your numerator. The first x squared just stays. Then you are distributing a negative 1 through that parenthesis. Okay, so that's going to be minus x squared plus 2x minus 1. So what do we end up with?
2x minus 1.
Yes, good. No, you do not. You can't cancel anything. Oh, x squared minus x squared is gone. Yes. I thought you were talking top bottom. Okay, okay. We're good. All right, guys, questions so far? Stop here for a second. I see some people still writing. Where what? Yeah, not quite as much as the trig stuff, but a little bit. All right, guys, let's try 3. Let's do just f of g of x. You guys try that one? F of g. Yeah. Sure. I mean, it's really easy. If you want to do g of f of x, it's quick. And guys, I want to point out something on the second one. I know I said we didn't have to do it, but square root of x squared plus 1, that is not x plus 1. It's just that. Think about, like, reminder with numbers. Let's say I had the square root of 9 plus 4. That's the square root of 13, right? It is not 3 plus 2, right? I can't take the square root of individual terms and pull them outside. Okay, so that x squared plus 1, just leave it alone. That's just hanging out under the square root.
Doesn't the power by 2 take out the root?
Okay, so do you think square root of 9 plus 4 is 5? Well, then why would you take out the square root of x squared?
Because there's a power 2 on the
Okay, great. This is 3 squared plus 2 squared. Quite a bit. You had 45 total. If you can, but you can't add x squared and 1, so you just leave. Like, this is just the answer. This is the answer of square root of 9 plus 4. Like, okay, let's do different numbers. What if I had... Yeah. Yeah. The whole thing got squared. Yeah.
Oh, 5 squared plus.
Yeah. Like, guys, do you think that's 6?
What's the square root of 26?
Yeah. But if you're wanting to do like the square root of each individual, you're like, oh, that's 5 plus 1. Like, no.
So we basically never
It would simplify if it was like x minus 1 quantity squared and the square root of that. You could then say, okay, that's x minus 1. But otherwise, oh, not the square root of x minus 1. Sorry. Like, that's that. That one would, yeah. Okay. All right, let's keep going. Somewhere. Just my next page. There we go. Okay. Do you understand it? All right, guys, questions on 3 before I turn the slide? That's it. This one is this. Okay. All right, guys, I gave you lots of room on this one because these take a little space. All right, f of g of x. Let me walk you through that one, and then I'm going to have you guys try the g of f of x, because I want you to practice these fraction ones. This entire fraction gets plugged in here and here. I'll show you. No.
Okay, that's fine.
Okay, step 1. Guys, stick with me one step at a time here. Are we good with that? All right, I can put the 2 over 1 and the minus 1 over 1. What do I need? Yes, so this is going to be times 2x minus 1 over 2x minus 1. Okay, be really careful with your negatives when you distribute the negative, okay? So I'm going to have x minus 4x plus 2 all over 2x minus 1 over x minus 2x plus 1 over 2x minus 1. You with me? Okay, we good? We good? Yeah, if you see it, guys, do you recognize that the 2x minus 1s are going to go away? I mean, you can go through the step of showing I flipped and multiplied, but if you recognize it here, just go, oh yeah, those are gone. Save yourself a step. Okay? All right, so what am I left with? What does that numerator simplify to? Wait, what? Top one, what does that simplify to? What's x minus 4? Okay, negative 3x plus 2 over
negative x plus 1.
Yes, that is your final answer.
Oh wait, so we don't. Oh yeah, oops, I tried to in my head I tried to do like, oh, there's a negative 4 and then negative 2. Those seem like.
Oh yeah, those, nope, just look, like isolate it, go, okay, what is just that?
Yeah, okay.
What is just that? Reem, are we good? Yeah?
Like the x and negative 2x plus 1.
Yeah, that's what this is. Yep. Okay, you guys try the second one. Let's see about
Why do the total of 56?
So it would just be like this. If I were to do x plus
talk to each other, see if you agree.
wait.
Okay.
You get x minus, yeah. I like it. I enjoy it. I think it's useful. I can do everything next time. I don't know. Yeah, I turn off the light when I can. The keyboard, so I can do this better. Yeah. The denominator if it's at like you're saying you can start at 100%.
Let's think about it. Is that 6 over 5 or is it 6 over 10? Yeah, right? Put it over 1. Because otherwise, like, that'd be like multiplying by 2 over 2, right? Okay.
This one's easy because on this, yes. Yeah. Why is it silent?
It's because I'm like, I have my computer. I can make it. I can do like this and then put it down. You got it? Yeah. And not really. I can put it down, but I don't want to score now. No, I don't know how to do that.
All right, guys. Did we get x minus 2 over x minus 3? Hey, guys. X minus 2 over x minus 3.
Yes.
Yes? Okay. Any questions on composition? All right, guys. Close your laptops. You don't need them right now. Leave that up there? Okay.
Okay, so this actually.
Why would you
Not doing domain.
Oh, is that when we distribute?
Distribute the -1. Yep, I know. That's the hardest part on this is the signs. Like not missing a negative. Hey guys, when you do this composition, please, please, please take your time when you're doing the common denominator and all that stuff. It is so easy to mess up a sign in the middle of this. Okay, like you forget to distribute the negative all the way through, anything like that. So please take your time. Yes.
Can I just show you my answer what I got? It's wrong. I got.
Just
Over 2x minus 3, but I know what I did wrong.
so did you distribute here to get 2x minus 4?
Yes.
Okay. Did you forget to take this 1 times x minus 1?
Yeah.
Okay. You need a common denominator. We can't just like swoosh the 1 in and say, oh yeah, wait a minute. Okay. Ben?
When you said that we're not doing domains, are you saying that we're not learning them yet, or we won't even be testing?
You're not going to learn algebraic domains. Graphically, like when we get to piecewise and stuff like that, you'll do it, but not like that's different. You got to work on some patience over there. All right. So that's composition. Let's now talk a little bit about function operations. So I'm giving you f of x and g of x. This is definitely different than anything you saw in Algebra 2. That's literally just those 4 points in f of x and those 4 points in g of x. So it's not like they're connected and it's some big graph, like it's dots. Okay? So what would the domain of f of x be? No. Yeah, literally just those 4 values, okay? So this is like really, really, really old domain that you did in like 6th grade or something. I don't know. What is the range of f of x? There we go. I don't care if they're in numerical order or anything like that. You just need all of them listed.
Oh, it shouldn't be in order.
I don't care. All right, domain of g of x. And range.
Shouldn't the other one be -2? F of x.
The domain is -2. Okay. Range of g of x, guys. Okay. All right. So to do operations with these functions, guys, you got to pay attention to this. It's very easy, but you need to understand what you're doing. So listen. Okay, to add the 2 functions together, so to take f plus g, you have to find common domain values, so common x's, and then you actually do the operation, the adding to the y values. So let's do the first one together. Do you see how they both have a -2 in them? Okay, so your first point, -2 is the x value. The y values of those points are going to add together. So we are adding 1 plus 3. 4. Okay, so yeah, you go to the next one. The next domain value in f of x was a 1. Is there a 1 in the domain of g of x? So I can't use that point. Okay, I go to the next one, was a 3. Is there a 3 in the domain of g of x? No, so I can't use that point. 4. Is there a 4?
Yes.
Okay, so we got a 4. And then what do I get when I add the y values? Okay.
Sorry, I understand the first one, how you put -2 and 4.
Okay.
Why do you, how do you get the 4 and the 5?
Do you see the common domain of 4 in both f and g?
Okay.
So that's the 4. And then it says f plus g. So I'm taking 7 plus -2. The y values, I do the operation. Which is so you already know it's going to be a -2 and a 4. Like that's going to stay the same. Yeah.
7 from the 4, and the other 4 is 4 -2, 7 -2.
Oh.
All right, you guys try it for f minus g. You already know the 2 x's you're going to have, right? Those are the only ones common. Find the y value. Yeah, because it's f minus g. So guys, order matters when it's subtraction. That is what that minus sign means, yes.
4, 9. I feel like we've done this before.
Minus, but it's going to be a plus. So it's gonna be
We've done this before, right?
Not exactly, no.
This seems familiar, though.
Well, that's good. Did you get -2, -2?
Yeah.
Okay, and 4, 9. Yes? Okay. F of g of x and g of x are different. Okay, those are composition. So let me walk you through this. And I'm actually going to do it with a marker out here so you can see what I'm looking at. Okay, f of g. Do you guys see how g is the inside function? Okay, that means I start with g. The input of a -2 gives me an output of 3. Yes? I carry that over to the other function. Is there an input of 3?
Yes.
What does it give me?
2.
Okay, so my first point here is the original input and the final output.
Okay, so
Yes.
I just have like
We're going to do all of those together. Follow with me again. 5 gives me 1.
Okay.
Does 1 give me something over here?
0.
So 5, 0.
But what happens if it doesn't give you one?
Then you don't write anything. Okay. All right, next one. 4 gives me -2. Does -2 give me something? Okay, so what's the point? 4, 1.
Wait. Am I writing -2? No, 4, and then we're -2. It gives you 1.
Yeah, so -2 is like the middleman. You don't write.
What do we use this for?
It's just so you understand how function operations work. If you haven't think about it.
So you just do them for any of them that have the same like numbers as the x and y.
So we got one more. 0 gives me 4.
4 gives you 7.
So what's the
So
point?
it's between 0 and 7.
Yes.
Okay.
Okay.
Then it's just the opposite.
Yeah, so guys, you try g of f of x. So you are now starting with this function. -2 gives you 1. See what you can get from there.
Wait, which one are you starting with?
The inside function.
No, 1.
Then you don't use it. Yep.
You're super bold.
There's only one for that one.
I think so. I go through it. -2 gives me 1. Nothing for 1. 1 gives me 0. 0 gives me 4. 3 gives me 2. Nope. 4 gives me 7. No. Are we okay with why it's just 1, 4 on that one? What do you mean? Why, you said why isn't it 0, 4? So 1 gave you 0, 0 gave you 4, 1, 4. The middleman does not get written down, okay?
Even for the f of GX?
Mhm.
Oh, I thought it
All right, questions so far? Anything?
Are these types of questions like that will be interesting, or is this what basic?
That's fair, yeah. Okay. All right, so let's try to practice some of these. You can do composition without being given the equation. You can just get the graph and then go from there for your composition. So let's look at this first one together. F of g of -2. So we start with g of -2. So which graph is the g graph? Yeah, okay. G of -2. That means when x is -2, what do I get for a y value?
4.
Okay, so you have to do f of 4. So when x is 4, what do I get for the y value? Thank you. 0. So your final answer is 0.
Okay, yeah, makes sense.
So I started in here, an x value of -2 is 3. That gave me a y value of 4.
Yeah.
Okay.
So then I take that 4 as the x value in the f function.
Okay.
And when x is 4, what is y? This is always the x. Your answer is always the
It's
y.
gonna be 0.
Yes.
Or y.
Okay. Okay. You guys try, these are numbered weird. Try number 3. See if you can figure that out. That's saying f of g of 2.
Yeah, will it be written like that? Will it be written like that?
It could be written this way.
So you said. This is x4. Yeah. So when the x is
I got 7.
when y is 4.
Wait, no, wait, you're.
Oh, so you can see
Do we look at the graph still?
No. Now you've got the equations.
Oh, no, so you just plug in 2, no, you just plug in 2 so it's not, no, 5 minus 2. No, 2 minus, oh,
2 minus 5?
-3?
I don't know. When we plug 2 in here, let's see.
It's just, don't you put the 2 for the x, so it's 2 minus 5.
But it's f of g of 2. You have to do g of 2 first.
I first put 2 into the g equation, then whatever I get from that, I put that.
Yes.
So 7 is
18 minus 6.
It's like 12 minus 5 is 7. Yeah, right.
Good job, Ben. All right, guys. Did I lose anybody on number 3? We doing okay? So f of g of 2, we start with g of 2. Plug a 2 in there. We get 12 out of it. You then plug 12 into the f. Yes, so it's just like 2 problems in 1.
I'm trying to find.
Yes, f of g of 2, but yeah. Yeah. All right, let's try again, guys. Okay, number 11 is kind of weird. Hey, guys, look up here. I'm asking you for -2 times h of 0 plus 2 times g of -4. I give you a bunch of weird things. I give you a graph for f of x, I give you an equation for g of x, and I give you a table for h of x. I don't even need one of these. Which one do I not even need to look at? Yeah, there's no f of anything in my equation, so just ignore that. So now use the table or the equation to try to figure out -2 times h of 0.
Plug 0 in the h.
0 is, it'll be
9.
9, and then 9 times -2.
minus h.
No. H of 0 is not 9.
H of 0, H is 0, it's 9.
It's not H is 0. It says H of 0. What is the 0 actually representing?
X.
Yeah.
Genius.
So it actually provides. My table weights are trying to, you know.
Whoa.
All right.
Do you see how it's labeled f of x? And there's no f in the equation. I don't know why it's even there.
No, it's
Wait, what's that?
What is the 9 again?
All right, guys, let's look. Okay. We are plugging into this thing. Guys, up here. So one piece first. -2 times h of 0. What is h of 0? 5. So I have -2 times 5. Okay, plus 2 times g of -4.
-4, and that's going to be 8.
No, g of x is x plus 2. So what is g of -4? Yeah.
-4, -2. Okay.
That didn't just say 2 times -4. It said 2 times g of -4. You got to figure out g of...
It would be -4 plus 2.
Yes.
Wait.
Exactly. All right, guys, questions on 11.
I still don't understand. H 0.
H of 0, that 0 is your x value.
So bring it down as a.
I get it.
Okay. All right, try number 9. It is very, very similar.
What is the T before the F of G of F?
Yeah, that means g of f of 10.
You don't need the graph.
Nope, you don't need the graph again. Graph is just there to take up space.
F of 10, so it's going to be -1. So G of -1 3 times -1
Oh, that's a graph.
No, it's positive. I know. Selling again. Okay, I get this.
Do mine too.
Yeah, I want to go home.
What are we getting, guys? +1, yes. Start on the inside, f of 10, that's -1. G of -1. +1, okay? All right, questions? All right, guys. Try 8. Yes, R of f of m.
So technically, No. 7x to the 4.
Okay, so we start with f of 10. So when x is 10, y is -1.
Wait,
So-
so this represents it?
Yes. Same thing like here. So where it was h of 0, when x was 0, h of 0 was 5. So we then do g of -1. But it's the input now on this, because when you do, like, so whatever we got here, right? Sorry, guys. So that was -1, and now we're
It's D though.
It says 2 over.
Because,
See it?
thank you.
Yes.
Dash.
There's not.
I
You just gotta think about it. You just gotta think about it. What? What are you talking about?
Boy, why should it be in the front?
Because no, it's to the power of. I mean, it's just how they wrote it. I don't know what you hear.
What should he be in the front? It's not in front.
I don't think it matters.
It's just so you recognize that entire thing as the exponent. All right, guys, the answer to that one was D. Did anybody get lost along the way? Okay, just got to go in order. It's ugly and weird, and you don't really want to evaluate it, but you can plug it in. Plug M into F, and then plug F into R. All right, guys, one more on composition here. Find G of F of X. Good. Ion, you done with 5?
Yes.
Rahul, you got 5 done? I don't know, I haven't actually done it yet. So just making sure you're done.
Oh, I didn't fall.
Miss Ford wanna go so right.
She ingrained this into you.
I used to sit in the front of her class.
I don't know, I'm doing it right now.
Yeah, Cal.
I'm doing it right now. Guys. Nope.
Why are you?
All right, guys. Did we get 10x squared plus 10x plus 15? Okay. All right. Are we good with composition? Okay. Even and odd. Because we still have like 40 minutes of class left.
What are we gonna do the rest of the time? Quizzes?
Well, we're not done yet. We got even and odd.
Yeah, we only got one more page.
Yeah, it's not going to take too long. Yeah, we'll either do whiteboards or quizzes. Probably quizzes. All right. Even and odd functions. So, guys, an even function is symmetric to the y-axis. So, like, y equals x squared is a good example of an even function. Okay, you could fold it in half along the y-axis. Odd function symmetric to the origin. Okay, what that means is that it has rotational symmetry. So like here's x cubed. Okay, draw that little graph on your paper. Charlie, got it? You drew that? After you draw it, I want you to hold your piece of paper up. Can you let me talk? Thank you. Hold your piece of paper up. Look at your graph. Rotate it 180 degrees. Compare your graph to my graph. Does it look the same?
Well, not
No, just the odd one.
Okay.
Even one's definitely not. Only this odd function. Does it look the same? Yeah, that's what odd functions do. They have rotational symmetry. Meaning if you rotate it 180 degrees. Okay, guys, I am dying talking over you today. I just can't.
I didn't listen to a word you said.
Are we ready? Okay. That is what rotational symmetry means. Any odd function has that. You don't have to prove functions are even or odd by graphing. We're going to do that algebraically, but that's just so you have a visual understanding of what an even and an odd function is. This part down below is what we're actually going to use. If I plug a negative x value in, if it's an even function, I'll get the exact same answer as if I plugged a positive one in. Like think about your quadratic graph. If I plug 3 in, I get 9. If If I plug -3 in, I get 9. Okay? Odd functions, you get the opposite. Okay? O with O here. If I plug a negative in, I get the opposite of what I did when I plugged the positive in. So your cubic graph, like plug a 2 in, you get 8. Plug a -2 in, you get -8. Okay? We can show this just by showing that we plugged it in. So when you're telling me if something's even or odd, you have to show work. So this first one here, f of x equals x squared, I need to show that I plugged -x in. What happens when I square a negative value? Positive. Do you see how that's the exact same as what I started with? That makes it an even function. Okay. All right, I can plug a negative in over here as well. What happens when you cube a negative? Still negative. So I get -x cubed. Do you see how that's the opposite of what I started with? When it's the complete opposite, that is considered an odd function. Okay? If it is just different, if it's not exactly the same and not the complete opposite, it's just not either. It's neither of them. It's not even or odd. Okay? All right, so let's, yes, question. Yes.
So, did we study this in algebra too?
Yes.
At the end.
I mean, I don't know where you studied it.
Okay, but we studied.
Yeah, it's an Algebra 2 topic for sure. All right, let's try a couple. So number 1 here, you're given f of x is 2x plus 1. The organized work you have to show. So that would mean write things down. Okay, f of -x. Show that you're plugging that in. So that'd be 2 times -x plus 1.
Always plugging -x.
Always -x, yep. So when I simplify, that becomes -2x plus 1. Compare it to the original. Is it exactly the same? No. Is it the total opposite? No. All the signs didn't change, right? The plus 1 is still a plus 1. Okay? So you would say neither. But if you don't have that work there showing that you did the f of -x and what it simplifies to, and you just write neither, you're not going to get credit for it. Okay, so you have to show your organized work. All right, so let's try g of -x. You guys try 2 and 3 for me, okay? See if you think they're even, odd, or neither.
Is this rocket science?
Depends. I should have everyone finished today, but I don't know about all the other pre-calc classes, so we'll see. And when you get it back, you just get to look at it, and then I collect it again. You don't get to keep comprehensives. I'd like to not have to completely write that test every time. It's a lot. Like, I'd like to use some of those questions again. All right, guys, let's go through them. G of -x. Show that you're plugging it in. What do you think? Same, opposite, or neither? Same, so even. Completely opposite, so that is odd, okay? We're going to make them fractions. Yes?
When is it neither? When is it odd?
Odd is when it's completely opposite. Like every sign has changed. Otherwise, it's not the opposite, right?
Okay.
Number one is not completely opposite. Yeah. All right, guys. We have to do this with fractions, too. That's the only part of this that gets a little tricky. So let's think about the fraction 3/4. What is the opposite of 3/4?
-3/4.
Yes. Would you agree that 3 over -4 is also the opposite?
Yes.
Right? Either the numerator or the denominator change signs. What if I have both -3 and -4? That's the same, right? Yeah, you see where I'm going with this. Okay, so when you do fractions, you need to look at the numerator. Is it the same or opposite? The denominator, is it the same or opposite? Okay, if they're both opposite, that's even. If one is opposite, one's the same, that's odd. So let's go through one together and then I'll have you try one.
Wait, when is it either? One is the same?
Yeah, so like, see how the -3 and the +4, we had an opposite in the numerator, same in the denominator. That makes the overall fraction opposite. Yeah. Or same in the numerator, opposite in the denominator. Yeah. But if they're both opposite, that's really the same.
Wait, what do you mean?
Okay.
So there's no.
I'll show you on the first one here, okay? No, it could be. If one of them is just not the same or not opposite, like if you had a 2x plus 1 in part of your fraction, the fraction's going to be neither. I'll show you. All right, let's do j of -x here. So plug it in, 2 times -x over 3 times -x cubed minus -x. So we simplify that. That's going to be -2x. Nope. Over -3x cubed plus x. Okay, let's check. Numerator to numerator. Is that same, opposite, or neither? Original numerator.
Oh, sorry.
Yeah, just numerator to numerator. What is that?
Opposite.
Opposite. Okay. What about original denominator to denominator? Opposite. So what does opposite over opposite really mean? Same. And what is same? Even. It's like you have a negative over a negative. They cancel out. It's really just the same thing you started with, okay? All right, you guys try number 5. Numbering has been an adventure on this.
It's all fraction.
Yeah, they were both
What is that?
the two odds made it like 2 negatives.
So in the exam, you will just ask the question, are these fractions odd or not?
I will. Let's go through this one first. Guys, what do you think? Even, odd, or neither for number 5? Okay. All right, squaring a negative, it stays the same. And this would be -2x cubed plus x. Guys, it looks like the numerator stayed the same. Denominator's opposite, so overall that is odd.
So like
Okay.
we're on stage.
That'd be even too. I'll show you a neither.
Oh, it's like one of the sides on top is different, but would you still give it to us?
I'd probably be like, what are you telling me?
Where should we write this?
You can just pay attention if you want. Guys, let's look at this one. Let me just go through it. So f of negative x, 2 times negative x minus 1 over negative x squared plus 2. Look at the numerator. It didn't do either thing. It's not the complete opposite, and it's not exactly the same. Yeah. So if your numerator or denominator is a neither, the whole thing is just a neither. Okay?
So if one of them is neither.
Yep. All right, questions? Okay, you guys covered a lot today. Yes, but first we are doing a quizzes. All right, yeah, you just said it. You have 10 minutes to spare.
Hello.